So once again, on problem number 3, we want to convert our original equation here of y equals negative x squared plus 6x minus 1 to vertex form. And while we're thinking about it, just a reminder that a is negative 1, b is 6, and c is negative 1 in this particular problem. And we can fill in the y-intercept right now. It is 0, negative 1, which is 0c. And we're allowed to do that from standard form. But really what our focus is going to be on is, can we write this equation in vertex form? So when we start this problem, we are going to put all of the x's on one side and the constant on the other. So we're going to take this value of negative 1, and we're going to move it over to the other side. Again, it is a personal preference. I'm going to write 1 plus y. There is nothing wrong with writing y plus 1. 1 plus y equals negative x squared plus 6x. Normally at this point, I would write a box in here, but we cannot complete the square because there's a negative in front of the x squared term. So our step 2, if you look back at the directions on page 7, says factor out that coefficient, the number in front of the x squared term. So we still have our 1 plus y over here on the left side, but we're going to factor out that negative 1. And when we factor that out, negative x squared divided by negative 1 is positive x squared. Positive 6x divided by negative 1 is negative 6x. And here at this point is where we will add the box. Here comes the box. And if we add the box on the right side, we need to add the box on the left side. And it's going to be a tight squeeze for me. But not only are we adding the box, but we also need to remember that in order to make this equation work out, we would have to distribute the negative 1. Negative 1 times x squared gives us our original negative x squared. Negative 1 times negative 6 gives us our original 6x. So this would be negative 1 times whatever is in the box. So not only do we have to put the box on the left side, but we have to put this negative 1 in there, and it's going to be negative 1 times. It's a tight squeeze over there. Negative 1 times the box over there on the left side. So we need to figure out what goes in that box, and then we're going to follow through pretty much all of our remaining steps the same, but we're looking in front of our box and we see negative 6. So this is going to be negative 6 divided by 2 squared. We're completing the square. We're forming a perfect square trinomial. And since we put negative 6 divided by 2 squared in that box, we're going to put it in the other box. And now we can simplify that, do a little bit better with my spacing here. So negative 1 times our box there, and over here on the other side we're going to have a negative 1. But negative 1, negative 6 divided by 2 is negative 3 squared, plus 1 plus y. And in our parentheses, we're going to have the x squared minus the 6x plus our box of negative 3 squared. Negative 6 divided by 2. We created a perfect square trinomial. So we're going to factor over here. In an effort to avoid the splitting the middle, I have it set up in this format. squared is x times x. Negative 3 squared is negative 3 times negative 3. The negative 6x is hidden in these two parentheses. In case you're wondering, on the other side, we can start simplifying. We still have our negative 1, but instead of our box of negative 3 squared, negative 3 squared means negative 3 times negative 3, which is positive 9. And then we have our plus 1 plus 1. And at this point, we are at the condense step. And when we condense, we've got x minus 3 squared times itself, mean squared. On the other side, we have negative 1 times 9 is negative 9. And we still have our plus 1 plus y. And we're on the last step now. We need to figure out what does y equal. But in order to get there, we have to start with negative 9 plus 1 is negative 8. And now we can finish. We're going to move that negative 8 to the other side. So we're going to add 8 to both sides. We end up with our vertex form of y equals negative 1 times x minus 3 squared plus 8. And let's type it into our calculator and check our work. So if we pull up our calculator, I'm going to go to y equals. If you've got stuff in there, clear it out. And let's type in the original equation, which is negative x squared plus 6x, only one plus, minus 1. And then let's type in our answer that we just came up with here, which is negative 1 times x minus 3 squared plus 8. And when we hit graph, we should have the same picture. And we did. The red landed right on top of the blue. If your calculator is slow, like my personal calculator is, go to the table, second, and graph, and look at your Y1 column, which on my screen happens to be blue, and your Y2 column on my screen happens to be red, and they need to be the exact same numbers. And if they are, we know that we've gotten the problem correct already. So let's take that information now and go back and fill in the rest of our table. Y equals negative times x minus 3 squared plus 8. And we actually wrote negative 1. So I'll put that in there. And then to finish this particular problem, we want to find our turning point, change the sign. Keep the sign. Our vertex is 3, 8. And lastly here, when you go back to the calculator, you can even visually check that. Does 3, 8 seem like a reasonable answer when we look at the picture? And it does.